Okay, a big hand for Yuan Xiao.
Thank you. Good afternoon. Good afternoon, everyone.
Yeah.
So before I start with my training proposal, I'd like to run some numbers with you. Okay, so just to recap all of us, keep us on the same page.
Try to speak louder again.
So do you all know that how much of the percentage Malaysia contribute to the semiconductor sector? Any guess?
Maybe 13%.
Global
1/3.
semiconductor market.
20%.
No, it's lower.
Actually, we are exporting a lot, right? So should be
Yeah.
more than 50%.
Okay, so actually we contributed to about 7% of the global semiconductors market, but in terms of assembly and test, we contributed about 30%. So in the semiconductor development, there's a food change, there's a value change, and 50 years since 50 years ago, 1974, we are focusing on the bottom maybe 3 categories, which is the assembly, packaging, and shipping. So that contributes to 30%. And we takes about 50 years to build this industry. So we invite all the foreign investment, we build all the ecosystem, and it took us 50 years. So last year, our government, Malaysian government, took a bold long-term strategy. So we defined something called a national semiconductor strategy. And this strategy is going to span for 10 years. And we're going to cover the value change, the full value change. And it involves how much capital, human capital you think we're going to involve this round in 10 years' time?
No idea.
Anyone have a guess?
50K?
Yeah, close. So we try to get to 60,000 human capitals. So you can imagine in the short term of 10 years, we want to build 60K of human capitals. But it took us 50 years to build the first 3 value change segments, and it contributed 30%. Of course, Malaysia government tried to get Malaysia into the map, become a global semiconductor hub. I think it's good for the country, definitely create a lot of jobs for the countries. Of course, this vision, the 60,000 human capital, it will be contributed from various areas. It will be many different industry that will get involved and build this whole industry. So this training, I only focus on one of the segment. So the top value change involve a lot of areas, but the key 3 areas that the government is looking into is the silicon design, the microchip design, the advanced packaging, as well as fabrication. So these are the top key areas that the industry really need a lot of supplies. It's actually not only the supplies that needed from Malaysia, but it's also a supply chain that is needed by worldwide. Malaysia has to contribute that. Okay, yeah, sorry. Yeah, so this training is specifically focused on that microchip design segment, and the focus is to try to help the industry to grow the human capitals. And the focus audience that we try to help is in for the fresh graduates from the school. The idea is that we try to accelerate their learning. Because typically when you come to the job, you will go through the on-the-job training. It may take you 2-3 years to get to something that effectively you can help to develop the product. And we try to enable, and by creating a design, a training course to accelerate their learning. Hopefully we can. I will go through the training objectives.
You have taken 4 minutes, 30 seconds. Sorry,
my name is C.Y. Cheng Yong. Okay, so I'm the beneficiary of the second wave of semiconductors when the government built the semiconductor. The first wave, as I mentioned, we're doing the assembly and test. I'm part of the design group. And now 30 years later, because the first wave is 50 years ago, the second wave was 30 years ago, and now we start another round of wave. I'm excited about it because I do see how the industry will go. So I've been in the industry for about 30 years, doing various kind of development, software, hardware development, and I also build a team, different level of leadership team, technical leadership team, and I'm familiar with some of the development process. Okay, so this training objective is to cover the design portion of the verification. Anyone want to guess how much percentage, in terms of development effort, how much percentage verification is contributing to it? That's assuming you only have a design and then you only have verification. With these two portions, how much percentage verification is contributing to the design?
60%.
Effort. Yeah, Sun is right, it's close. So about 70% of the effort is needed to do verification. So it's easier to do a design today because you can acquire different IP and then you do an integration. Just like a Lego product, you integrate product. But the challenge part is to how do you verify the integrated product. And potentially you may also do your own IP because you want to have some feature specific. So you do your own IP design. And in this case, then of course you do the design and the verification. So a lot of time you spend on verification. And why we spend so much on verification? Because we are not afford to find a bug after you fabricate the product. And then we found after that, each of the spin is about $1 million. So we have to be thorough to make sure the design meet the specification. So this course will teach the participants on apply the new techniques called system Verilog. They will learn about all the basic Verilog techniques, which I will go through later. Details to go through Verilog programming language, and of course we will teach them all the various verification techniques and how to debug and ensure a product is meeting the specifications. Okay, the diagram I'm showing here is the infrastructure. Eventually they're going to build this infrastructure. Obviously they can reuse from their previous product. They will build this infrastructure and then testing the design of the product, that whether it meet the specification. And the outcome of it is to enable more people to be able to do design verification. And
Can you go back to outcome? Okay.
And then when I start the program, we will start with the icebreaker. And typically in development, we sit in a conference just like this arrangement, and sometimes we are in cluster. And so the ice breaking I will do is having group of people sitting around them and try to introduce themselves and get to know each other. And then we will run some of the the level set between what the attendees' expectation versus what the cost will be offered, and try to level set on what they will be getting out of this training. And the first module is primarily focused on the industry. What is how is this chip being made? So we go through with them, the industry ecosystem, and then help them understand about microchip design overview, the process, the whole entire process, so they can have some good view of it. Because your career will not stop at the verification, you can move around with the understanding of the flow. You can grow your role over time. And then, when to apply verification in the process of the chip design flow, and understand about why we need to do verification. As I mentioned earlier, it's more expensive when you start validating your product at the tail end of the process. So you can see the 64x more expensive than you discover earlier and you validate it. And will get to, then eventually we will start them with some hands-on to start building up their built environment and getting them familiar with the system. So in this case, because some of them may not be very familiar with the system, so I will do a mirroring. I will show them how to set it up. I will get them into some of the basic things so that they will be able to follow through the whole entire course. And this course is actually offered for a week of a course, and today I'm showing you the first day of the course. Okay, and then after the first module, we will have a short break, morning break, and then we will start with module 2. And module 2 is really the beginning of it. They will learn all the basic terminology, the syntax used in the programming language, all the basic stuff. And then they will start going to more complex, how to control a flow, just like how the traffic light is happening in our group. They will start doing how do you control the flow of the design, like loop flow, all those basic ingredients in order to be a good programmer. So to help them get through that, and each of these classes will be offered, 30 minutes of the lecture, and then followed by 30 minutes of the lab exercise. So they will kind of try out all the instruction they learned on the field. And then after that, we get into the lunch break. We spend 50%. This is an intensive course and COVID time. Just we needed to control, because this is a course that we're going to offer someone that may not be familiar with the area. So we need to observe, and we take the attitude of learning how we going to train these people. So the time is compressed, and we try to learn through it, and we only give them like 15 minutes of the lunch. And after that, we get them to do some stretch, because the following 2 modules is going to sit down and continue to do the programming learning. And in module 3, and they are follow-on of a more complex thing. They start learning about the processes among the module. They will learn some of the intercommunication between the module. You can see the diagram here. There are many blocks, and how each block talk to each other. They will start learning about interaction between blocks and how do you send messages to each of the blocks. Basically, it's create infrastructure so that you can test the product, and then you set up your environment and infrastructure to do that. Okay. And then after that, we will have an afternoon break. Yeah, and 5 more minutes, I think.
2 minutes.
Okay.
2 minutes.
Yeah, and here, for those of you who are familiar with the C++ object-oriented programming, so in the system Verilog, they do have a similar behavior. We try to take the goodness of the C++ and implement in silicon verification. So we will learn some of the context of COO and how you apply COO in the design verification, of how there are certain differences. They will learn through these classes. And then after that, we'll give them the simple, this one before, right? Yeah, okay, yeah, sorry. Then after that, we'll give them the simple project, because they learn all the basic knowledge in order to do the programming, to verify the product. They learn how to control the flow. They also learn how to communicate between modules. So they already have equipped with some basic knowledge. Then towards the end of the day, about an hour or so, we give them a simple project and have them try it out themselves. So for this case, depending on how they do the assignments, and we may add the mirroring, I may showcase to them how to do certain steps. And we will use this project, simple design verification project, as a way to gauge how much have they learned, are we going to faster pace, and depending on the participants, we will adjust it accordingly for the following days. And this is the agenda, so we will spend like 8 hours together, minus the lunch and break, so it's 7 hours every learning the concept and hands-on practicing all the things that they learned through the lecture. Yeah, so that's about the course that we are offering. Our goal, just to wrap up, our goal is really try to help people that are not familiar. For example, those working adults that see potential in them and have passion and wanted to reskill themselves into this area. We also like to train them to help part of the human capitals. And of course, for those fresh graduates, whether there's an engineering background or adjacent to engineering, like mechanical engineering, we also would like to train them into this area. So hopefully this class will excite you, and you see the good future of Malaysia. Thank you.
They can have one or two questions. You all can ask.
I didn't prepare. I was prepared for my presentation.
It's okay, you know him well, so just ask.
That's got some questions.
Yeah, sure.
Just now you mentioned it's a 5 days program, right?
5 days project.
Yeah, so 5 days program, since it's a technical program, how much does it cost roughly?
It's a test, so thanks for the questions. How much this cost on the cost? So, we were thinking, okay, because we are trying to get the government project. So in this case, we are on their way to the training providers. And I don't know how much that was related, but what we do know from Penang point of view, there's this service provider called Penang's Skill Development Corporation. So we have about 60 million of funding. And the target is to grow 500 people in 5 years. And we are paying the trainer. I don't know whether I can disclose what. In the range of 2,000 per day for the trainer to train. So I think that's the number that I know. So, maybe I hope that you can help to distribute, to share this knowledge with your networks. So whoever join this program, it will be given an allowance. So say for example, I'm a fresh graduate, I found a job, I'm interested in this, I will sign up to join this. So when you join this program, we will give you so-called allowance or salary, 2,000, 3,000 something as a monthly salary. So this program, we're going to run it for, there are different programs. So when you attend this program, you will get the allowance, and it's actually funded part of the money that I was talking about. And there are also many other design centers, because I think Malaysia is trying to grow. Right? So Penang has been started with the semiconductors sector, and now Selangor also building up. You probably hear a lot of news about Selangor's design center. In fact, it's just right here, Puchong, BFCC. So they are building up the design center, and then in Sarawak, they're also building up a design center. Each of us focus on slightly different area, but the goal is the same. Right? So try to be a semiconductor hub. I hope I answer your question.
Thank you.
Okay, you can for Mr. Siang.
I'm sure I need you to have that look.